To warmly welcome you to this session on MATLAB programming fundamentals via projects. Our focus today will be graphics, okay? That will be our focus for the session of today. And I am very, very, very excited because we'll have to learn graphics, advanced graphics brutally, okay? But don't worry, everything will be explained. It will be taken step by step such that even a mere beginner is able to understand. Now, before we get started, there is a notion that I want to take out of the way. You should not say that this kind of programming is not for you. Never say that. Whether you're an engineer, whether you're a mathematician, whether you are a business person, okay, no matter the field you specialize in, don't look at this programming necessarily as something that will help you in your field per se. Okay, be open to get the skills to program anything that you want, that you think about. Get that skill. It will help you because you never know where a programming project can fall. Okay, so the purpose of all of this is to be able to initiate the masses into computer programming. No matter who you are, programming is for you. It's not for a given set of people. Okay, so that being said, today we are not wasting time in introduction of computational engineering. We are not wasting time in knowing who I am. We are not. No, we have a lot to do. I prefer that we dive straight into the technicality so that we maximize your time and make sure that you go here with enough value as expected. Okay, so. mm I will be expecting you guys to participate, okay, at the level of the comment section. Please tell me how you feel at every single step, okay. I will not be focusing on the comments. I have a team that is focused on that, okay. But if you have any questions along the way or any comments, please make comments, okay. Just discuss, just say how you feel as I'm explaining, okay. And any questions and all the like, I have a team that is looking that up and summing it up, okay. So at the end we might have time to answer the questions, not necessarily even here, okay. If you switch in, if you subscribe to our channel, okay, we will upload videos that answer your various questions, okay, and you will be notified automatically if you have subscribed and hit the notification bell. That being said, no matter where you're watching this video now, please, uh in future we will no longer be using this wonderful platform, okay, because some people now are watching it on webinar jam, other people are watching it on Facebook. We will no longer be using these other wonderful platforms, right? We will be focusing on YouTube. So I will plead that you take some time off and go to our YouTube channel. To get there, just go and search on YouTube Computational Engineering Academy. Okay, you will see our channel appear. You cannot miss it. You know the logo. So you take Computational Engineering Academy and then you subscribe to the channel. Please do subscribe, and you also hit the notification bell to make sure that you are informed every time we are live or every time we upload a new video. Okay, we are bent on getting everybody to learn simulation, to learn modeling, to learn computing with MATLAB. Okay, that is our goal, that is our focus. So we will be uploading a lot of useful material that will rapidly take you in MATLAB from zero to pro. So that being said, let's dive straight into the matter. What you have in front of you here, I'm sure many of you are surprised. Say, what is this? Well, it is the AutoCAD software, okay? It's not about it. I want to use the AutoCAD software to somehow illustrate what we are trying to program today, the exercise that we have at hand today, okay? So let me just remove some technicalities here. Let me remove these, okay? And this is what we want to do today. We want to draw basic geometries interactively in MATLAB. Okay, so interactively means we want to create some form of platform like this AutoCAD you're seeing here, with a drawing area, okay, and the possibility for a user to model, to draw any basic geometric object of his choice. Okay, so geometric object of our focus today will be a rectangle, a circle, and a line. That is what we will be doing today. Okay, so we will be doing it exactly the way AutoCAD does it. So look at this, sorry. If I click on line here, okay, what happens? When I click a first point, AutoCAD is ready for me to draw a line. When I click a first point, okay, that is the first point of the line. And as I move, look at what happens. Okay, are you seeing that? What happens is it is automatically trying to draw a new line from the potential second point I want to click. Okay, and the new line follows my mouse. We want this interactive behavior in MATLAB and allow people to draw lines in this manner. Okay, so when I click again, this line is drawn. The first line is drawn, but then from the previous point I have clicked, automatically, okay, a next line, I have the possibility of drawing a next line. Are you seeing that? And if I click again, okay, and so on. What you see, are you seeing those dotted lines that are following us? Okay. What does it measure? It measures the angle, okay, of the line, orientation of the line with respect to the horizontal, and also measures what? The length of the line, okay? It's two things. So I click again and I click again and the process continues. So this is what we want to start by. Okay, we want to start by programming this. This is a wonderful exercise. Okay, so without much ado, let's dive straight into MATLAB and see how, okay, and figure out how we can do this. Okay, so I'm in MATLAB and we will open the editor. Okay, so let's just go right ahead here, new script. We'll open the editor and then figure out how to do this. Well, listen, in MATLAB to draw a line is very simple. I told you many commands are the way they are in English. So to draw a line is simply the line command. So if I just type line, okay, and here we want to save our code before actually running it, okay. So let's call it draw, okay, draw basic, draw basic geo, okay, to say draw basic geometries. Good. So if I say line, when I run this, what happens? Okay, still waiting for it to come. Come on, MATLAB, behave yourself. This computer cannot choose to be slow of all days today. No, don't do that. Don't do that. Thank you. You see, at times you need to talk to these objects like that so that they understand some things, okay? Because if you don't, they can disgrace you in public. Okay, so this is it right here, right? So when I say line, MATLAB has automatically drawn a line. What you have here is a figure, okay? A figure is the parent object used for graphical user interfaces, used for graphics and all the like. You will understand that, okay, as we go along. That's why you should subscribe to that YouTube channel. Please subscribe because we will be going in depth into MATLAB, okay? Not superficially. We will be going real in depth and doing real life projects, and you want to be there. You don't want to miss this. It is an extra skill that will certainly be useful for you in this 21st century with where we are going to in automation. You want to have these skills. Okay, so that being said, this is an axis. Okay, the way you plot your axis on the way you have two sets of data, x and y, and you want to plot it. This will be the y, the x-axis, right? And right here will be your y-axis. So MATLAB has drawn a line automatically, as we said, line, and the original point here is the origin, which is x00, as you can see. Okay, and the last point up here is can I use to do the same thing? Okay, the last point up here, though we may not be able to see it because of the new tooltip that's up here. We have 1, 1. Okay, so what happens when you say line? MATLAB automatically draws any line, okay, of coordinates. First point 0, 0, and second point 1, 1. Okay, that's it right there. And second point 1, 1. Hope you're seeing that. Great. So let's start actually programming that functionality. That is not what we want. Okay, what we want, let me run that again, and I hope MATLAB would. What we want is, this is our graphics. We want an empty graphics here. And by the way, this here where MATLAB is drawing is called the axis object. Okay, you can generate an empty one. So for example, if I close this and I delete that and I just say axis, okay, and I run, oh sorry, I'm not in the command window, and I run, what happens? There's an axis that is being created, empty axis. Okay, so it is in this axis that we want to be able to click a first point, okay, and move. And what happens? A line should follow from the first point that we are clicking and going rather. So the problem is, how do we first of all even click on that first point? Okay, that's the problem. How do we click on that first point, and how do we know where we have clicked? Okay, and then how do we automatically draw a line to move? So let's start by clicking on the points. Okay, let's start by clicking on the points and being able to determine or get the points that we have clicked on, right? Good. So this right here, this axis you see here, is an object. Okay, you have to see it as an object, and this object, we can control it in our programming by simply saving it in the variable. Okay, so what happens? Let me close this. I have simply said axis here. Okay, it has created an axis, but if I want to be able to control this axis in the long run, okay, I can just say A, for example, should be equal to axis. Okay, if I say A is equal to axis, then I'm in a whole different ball game here. Okay, so now if I run this, okay, what happens? This axis here, this object is stored in the variable A. And if I even go to my command window, where is that? Okay, if I go to my command window, I'll notice that here, rather on my workspace, this is the object A that has been stored as an axis. Okay, so now this axis here is an object and it has properties. Okay, it has properties. For example, here you have the x-axis, here you have the y-axis. Okay, I can change the limits of the x-axis. Here is going from 0 to 1. Okay, I can change, this is the y-axis, sorry, I can change the limits of the y-axis. Here is going from 0 to 1, right? I can decide that, okay, I want the y to go from 0 to 5, not from 0 to 1. Okay, how do I do that? I have my axis in my code that is represented by the variable A. Okay, to do that, I'll use what we call the set command. Okay, the set command enables us to change a particular property of an object. So I will say set is like in English, huh? It's like in English. Set this value, set the value of x to 2, set the value of y to this thing. Um, you get the point. It's English. If I say set, it means I want to change a certain value, or I want to ascribe a value to something. Okay, so you will say set, and then the first input that the function set expects, I think I should try to just press the bracket here so that MATLAB shows us some things. Or let me open the help. Okay, let me open the help and try to look at that set. By the way, you should learn how to use the help documentation of MATLAB. You should learn how to use it because it is priceless. Okay, it has everything that you need. Whatsoever you're looking for in MATLAB, in some shape or form, it is found in the help documentation. Okay, so you should learn how to use this as your main source of whatsoever you're looking for. Just come and type, okay, and you press enter. Very, very useful, very helpful, and it has a lot of great tutorials on getting started with MATLAB, which if you follow step by step, you will be good to go in no time. So look at it, says set graphics object properties. This is what we want, okay? So if I click there, set graphics objects properties, that's what we have, right? So okay, do not use. We are not on Java. We are not on Java. We're not using Java objects. Okay, we are sorry, and we've taken note of that. Okay, so this is the syntax that you have to use. So it is set. Okay, H here represents the name of the object. Okay, and the name here represents the name of the property, and here it is the value of the property. We can read it here. I think so. Set H comma name that. What does it do? It specifies a value for the property name. Okay, this is the property on the object identified by H. So this is the variable that represents the object whose property we want to change. And they say use quotes around the property name. Okay, for example, if you want to change the color of the object H, you will use quote around the property name. Okay, and this word, this is the value that you want to ascribe to the color. So what you're saying in set H comma color comma red is that you want to set the color property of this H to be what? To be red. Okay, so let's see that in action. Let's see that in action. So I think color is a very good example. This is our object, remember. So our object is stored in the variable A. Okay, so we want to set A comma color. We want to set its color property, okay, to, let's use the same example and say red. Okay, to red. So don't look at this and say every color will work. The basic colors will work. Yellow, green, black, and all you work. But you should, it's another thing to learn colors in MATLAB, okay? Because colors are represented by three vectors, by three element vectors, okay? One represents a combination of three element vectors, what we know as the RGB, the red, blue, and green combination, okay? That vary from 0 to 1. It's another topic on its own. I think we'll deal with that in a later project, okay? So, or you can still go ahead and follow our MATLAB programming course on YouTube. Okay, we have a whole programming course on MATLAB on YouTube that can lead you on that. So though we've not yet covered that section, it's still coming. So if I do that and I press enter, look at this. Are you seeing this? My axis has turned to red. Okay, so with this A, I control every property. By the way, this is not the property name is not something you guess. Okay, it's not something you get up and say I want to change the size of this A. Let me just go ahead, set A comma size. And then you don't even know the property that you put here. Okay, okay, I think that thing is a square or it is a rectangle. Let me just try to put a vector here, maybe, and say, I want the breadth to be 5, and I want the height to be something like 4. What does it give me? Okay, so let me run again. Okay, so it doesn't work this way. Okay, it doesn't work like that, right? So to know the properties of axis, again, the help documentation is very useful. If you come right here and you type axis properties, okay, axis properties, and you press enter, you will have a whole section here talking about axis properties. Okay, so these here are the properties of axis. Okay, you see that? So this is to change the font name and all the like. If you're giving labels to the axis, so the X label and the Y label and the title and things like that. Uh, So all of these are the properties. These are the things that enable you to manipulate the axis as you see fit. Okay. So for example, here you see rulers. You have x limb, y limb, z limb. These are the properties that control the limits of the axis. So for example, um, here my axis is goes from 0 to 1. Why? Because the x limb property is set to, as you can see here, by default. Okay, by default, the y limb property here, this value here is controlled by the y limb property. Okay, and the y limb property by default goes from 0 to 1. That's why you see here 0 to 1. The x limb property goes by default from 0 to 1. That's why you see here 0 to 1. So as we were trying to say, if I want to change here from 0 to 5, what happens? I need to come this way. Okay, I need to come this way, and then I want to set. My recommendation is that you always write the names of the properties, no matter how they are given to you here. Okay, write them in lowercase letters so that you don't have to stress. Okay, so you have, I want to set the y limb property. So I'll say, we'll put the names in quotes, as they said, the y limb property, and I want it to go from 0 to 5, as we said. Okay, so you create a vector in there. Okay, the first value represents the smallest, the minimum value in the axis, and the last represents the largest value. Okay, so if I go ahead and press enter here, what happens to our axis? It now goes from 0 to 5. Okay, it's no longer 0 to 1. So that was a brief introduction to understanding how these things work. We shall be using this because even the line is an object. Okay, the line that we're trying to draw is an object. Okay, still together. Good. That being said, we were saying all of these because we want that when we click on this axis, okay, we want to be able to get the point where we have clicked. Okay, we want to be able to get the point where we have clicked. So how do we even know? How does MATLAB know that a user has clicked on this axis? Okay, what we use is what we call the button down function property of the axis. So let's go ahead. Where is that? Where is that? Where is that? Button down function. I think it's at the level of callbacks. Okay. They reorganize these properties in a very, very nice. Wow, wow. That's so awesome. I said MATLAB documentation is the place to go. It is the place to go if you really want to master. You have any difficulty, just go there. So this is it. This is the property that we use. Button down function. So it is a mouse click callback. Okay. So when I say callback, it means it is a function that executes itself when a particular event is provoked. So for example, clicking is an event. Okay. Clicking is something that you've done. So if you want something to happen when you click on the object, then you should program a function and store that function in what? In the button down function right here. Okay, property of the button down property of the axis. Okay, so that being said, we should go ahead and do that right away. Okay, so we'll go back to our editor, or where's that? We'll go back to our editor. Good. So what we are saying, we want an axis. Let me just put here semicolon for the sake of now, because if I start opening some things here, but we will change some things. Okay, I just don't want to do it now. So a is equals to axis. Now I want to know, I want to actually know when I have clicked. Okay, so I will say a. Okay, I will set, rather, okay, A's property, which we'll call the button down function. Okay, I'll set it to a certain value. Okay, now this value Though it can be just one straight line, okay, something represented by a command or something. But what we want to do here is actually to ascribe to it a function. This value is a function, okay? And we'll implement Cramer's rule for now, okay? So we'll say that we'll create a certain function that will give us, that will be able to get the point where we have clicked. Okay, so how are we calling that function? How are we calling it? Let me just say axis click. Why not? Okay, and the way MATLAB expects us to actually give this function to the button down function is simply by adding, okay, and add yao an at symbol there. Okay, this is it. You add the symbol and then you give the name of the function. But there is a problem here, right? There is a problem. Why? Because this function is not created, right? This function here. So it means if I run this, there will be a problem. There will be an error. Okay? Let's go right away. Did I run it? Let's clear the screen so that we are okay. Good. So let's run this. Okay, there will not be any error, right? There will not be error when I run it because the function is not yet executed. It has just been stored. When would the function execute? The function will execute when I actually click on the axis. Okay, you remember this is when we click on the axis that the button down function executes. So when I click, what would happen? They tell me undefined function axis click for input arguments of type da 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 da. Okay, this function has not yet been created. So if I want something to execute itself when I click, okay, what happens? I need to create that function. So that's what we'll do right away. So let's just go back to our editor and then create the function. I'll just say plus here and we'll say function, okay, axis click. And another Cramer's rule is that every callback must have at least two input arguments. You have what we call the source, okay, and we have the event. Okay, these are the two input arguments that are expected, and we want to have an end to this function here. So let me save that first, then we come back to explain. Okay, so it's very simple. The source here, right? The source here is the object itself. Okay, this axis here is the source. That's it. So the source is the same like this A that we have here. It's just the same thing in this case scenario. So in general, when you are writing a function for a callback, okay, the source value of that function is the object whose callback is executing. That is how it functions in MATLAB. Okay, and the event here, I'm not sure it's in the scope of this lecture. Okay, but for events here can be, for example, a key click, okay, or a key press rather. If I press T, if I press A, if I press delete, something like that, that will be the event. But that is not our focus for today. Okay, we'll cover that later on. We have to really be very, very, very precise if we want to cover what we have to cover today. Okay, so since this event is not useful, I will have to replace it by the tilde symbol, this right here, okay, because it will not be useful, right? What we may need is the source, okay, which is the A object, you remember, okay, which is the axis itself. So what do we need from the axis when we have clicked? I want you to know, first of all, that I want you to take note of something first, okay? At this level, when I run this program now, okay, and I go back to the command window and press CLC, okay, when I click, what happens? There's no longer any error. Why? Because our axis click function has been created, but also at the same time, nothing happens. Why? Because there is no line of code to execute within our axis click function. Okay, so we want to go to the axis click function and put in some codes so that these are the codes that will execute. So this is where you write what do you want MATLAB to do. What do you want MATLAB to do once they click on the axis? This is exactly where you write it. Okay, so how do we go about that? Well, the axis has what we call a current point property. Okay, will I be able to find it here? We don't want to waste a lot of time. Okay, let's just browse. You should know what you're looking for. Huh? You should really know what you're looking for from time. Okay, right here, a current point property. Okay, so they say location of mouse pointer. Okay, it specified as a 2 by 3 array right here. This one. Okay, so these are this is a 3 by what's happening? A 2 by 3. This is a 2 by 3 array. Okay. On the first line, you have X front, Y front, Z front. Okay. On the second line, X back, Y back, Z back. Okay. And this is more, it is better explained if we were dealing with 3D objects, while we have an X front, Y front, Z front, and X back, Y back, Z back. Okay, because when you're in the 3D geometry, you want to know exactly where you're clicking. Okay, so that is where this is useful. But in our case, we will have X front, Y front to be equal to X back, Z back. Okay, so Z front, Z back, we don't even need it, right? Because we are in an XY plane. But here you have the help, okay? If you want to go deep into this, you can always come here and then click some things, okay, to be able to get more value. But our focus is to say that our axis has a current point property which tells us exactly where the mouse pointer is found. Okay, it gives us the x and the y coordinates, okay, of exactly where the mouse pointer is found. So in order to get the value that is found in this property when we have clicked, I've already given the name of the function in saying making that statement. The name of the function is simply get. Okay, so when you want to set a particular property of an object to a certain value, what do? You use the set function. When you want to get a property from, okay, from an object, you want to get the value of a property from an object, you simply use the get function. So what we are going to do right here is simply say get, okay, here A is no longer available, okay, to control, but we have what? We have source, okay, source, which is what? Which is the axis itself. So we are saying get source, the axis, get current its current point property. And you notice, okay, the way they've given the property here is capital C, capital P, the camel case way of nomenclature. And here we write everything in lowercase. Okay, this is in order not to think too much. I recommend this. Okay, but again, you're free, right? You're really free. So now this is a line of code we want to execute. So now let's see how the axis behaves when we click on it now. Okay, so when I click, pop, look at that. Okay, so there is this array. Remember, this is X front, Y front, right? Z front. This is X back, Y back, Z back. Okay, so I click again and look at that. Okay, so let's try to see. Let's just try to approximate. This is 0.5, right? This is y equals to 0.5. So let me try to go somewhere around x equals to 0.1, and let's see whether it gives us an approximate. I will not be able to click exactly on that point, but you see what I mean. So if I click there, bam, what happens? Is that even correct? Okay, yes, that's correct. No, it's not correct. No. I say yes, it's correct. Yes, it's very correct, right? So here we have 0.09 for the x, okay, which approximates towards 0.1, okay. So if I just shifted again a bit to the right, I would have gotten my 0.1. And here we have 0.49, which approximates to what? 0.5. So what do you see? You see that this value here and this value here are exactly the same. What varies is this z, okay? Because of we cannot explain that today. Okay, let's focus. I'm tempted to explain this, but it will take another round of let's focus. We cannot explain that today. Our focus is x and y. Okay, so what does this mean? I will not need all of this array. Okay, I will not need all of this. I'll just need these first two. That's all I need. So you see now an application of matrix indexing. Okay, the fundamentals we saw in last webinar, or the fundamental you can find, the fundamentals you can find in a programming course in MATLAB. Okay, in the YouTube channel. They contain all the basics that you need, okay, and you will implement them over those are the basics you implement over and over again in all the projects. I told you everything can be modeled via matrices, okay, and you need to be able to manipulate matrices in MATLAB. If you know how to do that, you are an expert MATLAB programmer. That's how easy it is. Okay, good. So I don't need all of that. So what I'll do at this level, again, please subscribe to the YouTube channel, okay, please do. And if you know your friends that want to learn MATLAB and all the like, send them to this channel. We will constantly, from now henceforth, we will be live on Saturdays, true, but we'll also be live on different days of the week, okay? And you want to be notified when we are live. You want to be informed when we are live, okay? And your friends too. So please, get people to subscribe, and that is the way you're making us to grow. That is the way you are also telling us thank you, and that is the way we too are also telling you thank you, because you make our work at the Computational Engineering Academy relevant. Okay, so at this level we will store the value of age, or rather we'll store the value of the current point. Let me just create a variable cp to say current point is equal to that. Okay, but then we don't need all of that 2 by 3 array. What we need is just the first two elements, okay? The first two elements. So we'll say CP is equal to CP of what? 1, okay? Those elements are found where? In the first row, right? They are in the first row, and what? The first two columns, okay? So we'll say 1, comma 1. This is matrix indexing application, okay, and we have that. So let me remove the semicolon so that we can echo the answer and see what happens now. Okay, so on the command window I will just press CLC. Okay, let's go ahead and see what happens. When I click now, you see that it's now the XY coordinate, full stop. That's what we want. Okay, that is all we want. Great, that's been done. Okay, that's been done. So now we have the coordinates of a point that we are clicking on. Is that not awesome? Okay, so I need to teach you something now which you have to open your minds to. Okay, so there is the possibility of me not actually having to create a new file here in order to create this function. Okay, I can actually have this function just right under here. Let me create a new section here. A new section here where I would just say callbacks. Okay, that proposing me live scripts. Not now. My audience is not ready for that. I'm not sure. So callbacks, right? And we can put that function right here. The problem is at this position, at this specific position. Let me go ahead and delete the other one. Okay, so that we are sure that that is the function that we are executing. Let me delete this. Is this a risk? No, don't do that. No, are you sure? Okay, so we've deleted that. So if I run this again, Let me close this. If I run this, okay, and we go now to when I click, okay, you see that? So there's actually a possibility of placing the function directly under my script, and it's still working, as you can see. Okay, good. Oh, I love MATLAB. I don't know for you, I love MATLAB. Okay, it makes life so much easy. Okay, good. So we've done that. So at this level, we have the coordinate of the point. Okay. What happens from then? What happens is that when we move the mouse, okay, when we have clicked and we move the mouse, okay, just like AutoCAD, let me remind that, okay, hmm, okay, sorry, let me delete all of this. So when we have clicked and we move, we want a line to be able to follow our mouse the way it is following right here, okay, that's what we want. You see that? Oh, this is cool. Okay, so how do we do that? We have to be able to track the position of the mouse at any given time t. Okay, we have to be able to tell where the mouse is found at every given time t. And this unfortunately is not a property of this axis. Okay, it is a property of this figure. Okay, when you start dealing with graphics in MATLAB, it's important for you to understand everything in terms of what MATLAB calls handles. Okay, so you will have to be able to know that every single graphic is an object. It is an object, just like the axis here is an object that has properties. Okay, so button down function, for example, here is a property. The color is a property. The X-lim is a property. All of them have properties that you can manipulate in order to change it according to what you want. Okay? So, for example, at this level here, I must not even create a variable to store this axis. Okay? I can just go ahead and all of these properties, okay, I will create axis immediately with those properties. So let's do that. Okay. In this case, I don't need the semicolon. I'm not ascribing anybody to anybody. Okay? So if I do that, what happens? It's still the same behavior. I've changed nothing. Okay? I've simply said create the axis object. Okay? But instead of creating it in the standard manner, I've created the object and immediately I'm giving it its properties, its property value, its property names and values. I'm giving value to its properties immediately. Okay, so here I can just create an axis, for example, of color. Where is that? An axis of color. Let me say blue, for example. I can just do that right away here. No stress. So let me close that. You see that immediately. So we don't want it to be blue, obviously. So let me just go ahead and delete that. It was just for the sake of illustration. But I was saying that when you go ahead and move on this, okay, the property that enables us to track where the mouse is found on this parent object is this figure. Okay, it is this figure that has that property. So let's just go right ahead and look for it so that you understand what I'm saying. If I click on a plus here, because I don't want to leave my axis properties, if I click a plus here for MATLAB to open a different documentation page, and I look for figure properties, okay, press enter. Okay, these are the figure properties right here, and these are the different colors, by the way. Okay, these are the different possible colors. You have red or R, which we use today. We have green, or we have blue or B, which we also just used. Okay, these are the possible colors that you can write as text. If you don't want any of these colors, then you can always do a combination, right? You can always do a color combination. Okay. Callback, 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 callback. Callback should be right down. I think so. What was that? Okay, interactivity. Mm, common callbacks. Okay. Uh, common callbacks. I'm seeing create function. I'm seeing button down function. I'm seeing that. Okay, window callbacks. Request that. Select that. Hmm, hmm. Okay, so this is window button down function. So when they say window function, it means it will work. So the moment your application is opened, no matter what happens, that is what will work. Okay, it's a long story. Okay, I'm still not finding what I'm looking for. Have I skipped it? I must have skipped it, right? Because it's supposed to be at the level of the window callback. Hmm. This is resize function. um, uh, this is Windows scroll function. We don't want that. Window key release function. So this function does what you read. Okay, this to say that if you press a key and you release it, this is the function that will execute. If at all you give a function value to this property. Okay, window key press, when you press a win, and these are the cases where you need that event that we just neglected in the second argument that we neglected in the callbacks. uh Windows button motion. This is what we are looking for. Wow, that was hard to find. This is what we are looking for. Well, not hard to find, it was hard to find for a live session. Okay. Okay, so it tells you Windows button motion callback. Okay, specified as one of these, a function handle. Yes, this is what we use, a function handle. Okay, we ascribe it the value of a function. Typically, this callback function executes whenever the user moves the pointer within the figure. Okay, so this is our figure. Whenever we are moving, this is the pointer, this arrow you're seeing right here. Okay, my mouse is a pointer. So as I am moving it, that function is executing. That's what it's saying. Okay, whenever we move it within here, that function is executing, and that's what we want. Okay, we want that as we are moving, the function should be executing so that our line can be drawn as the function is being executed. Right? Good. Um, what is that? However, if the user clicks and holds the mouse button and moves the pointer outside the figure, the Windows button motion function executes while the pointer is outside the figure. I don't think we'll have that application here. Okay, so let's go ahead. So it means before creating the figure, the axis, actually we'll need to create the figure. Okay, to create a figure, an empty figure, and we'll even make it more exciting now so that you see some things. Also, let me close this. CLC, the figure is the parent. Okay, this figure you see right here is the parent. If you want to do applications in MATLAB, you want to develop applications, you want edit text, you want push buttons, you want list boxes, you want check boxes, radio buttons. This is where you create them. Okay, this is where you put them and position them and all the like in order to design your application. Then you put callbacks, you give them all types of functions for them to work according to the way you want it to. And we will be doing again, subscribe on YouTube because we'll be doing a lot of application of that. Okay, that being said, this is the figure. You see that it opens up, and because we're not plotting anything, there's no axis here. Okay, so all of these things that you see here, okay, have properties. For example, I can decide to remove all of this top part here. Okay, what do I need to do? um Oh, should I introduce GCF here? No, it's not really important. Okay, so I will need to give, let's close that figure again. Sorry. I will give my figure, I'll store it in a variable. Let's call it A again. There's no problem. Okay. So now a figure has been created, and it is this A that represents that figure, as you can see. And A is equals to figure 1. These are some properties that they give you. Okay. So I want to set, okay, uh, the menu bar property. Okay, it's called menu bar. The menu bar property of A. I want to set it to, is it none? Is one of the values? Is it off? Okay, it's none. If I do that, look at that. The figure is empty now. All of these things have disappeared. Okay, so these things show with respect to the type of menu bar that you chose right here. Okay, so also I can set a title to this figure. Okay, I can set a comma how do you spell that title again? A comma title. Let's give it my basic Joe. Yo. Okay. So let me do that. What has happened? Oh, sorry. The property's name is not title. Okay. So you see here, it's a very good example of what we saw. It's name. Okay. I think it's name. It's not title. We'll have spent the whole time on the help figuring that out. Okay, its name, you see, this is my basic Joe, but it appears in front of this figure 1. Okay, if you don't want to see this figure 1, you simply set the number title. So you see, everything is so, MATLAB is so flexible. It's so flexible. You simply set what we call the number title, okay, to off. And if you do that, we have just my basic Joe right up here. But all of that was to show you some properties, okay? Just to show you this figure, okay? Good. That being said, we can go right here, and what we'll do now is to create a figure first, okay? The way we'll create it is the same way we are creating this axis here. We'll just put some properties in it, okay? No need to create a variable and then set it. We just put property name. What are we giving? Property name. What are we giving? We set the name, okay? Let's just give it a title. Interactive. Let me just say drawing. Okay, that will be our title. We want the number title. We want the number title to be set to off. Okay, and we want what do we want again? We want the menu bar to disappear, right? Menu bar to be none. So all of these things, you can see them in the help documentation. Okay, if you browse through that, you can experiment yourself with all of them. Okay, and then finally we want to give it what, a button. Hey, it's a very long property name. Window, button, motion, function. I remember when I was cramming this name. Window, button, motion, function. Okay, that's what we want to give. And just like the button down function here, we will just give it the name of a particular function. Okay, so we will just say at what name are we giving this time? Let's just say mouse move. Okay, for example, or let me say line draw. Now, now mouse move. Okay, let's just say mouse move. Okay, that's what we have. So we want to create that function right here. Okay, look at this. Let me first of all show this. Now if we run, okay, this is what we are having. I want you to look at something. If I put here, you see errors. Oh my god, errors. Why? Because each time my mouse is moving, it's trying to execute that function. Each time it's moving, it's trying to execute, and that function is not yet created. Okay, so that's why you see undefined function mouse move here. So what does it mean? The function we are about to create will execute itself as many times as we are on the figure. Okay, good. So let's stop making MATLAB suffer. Okay, so let's just go ahead and create the function. We'll say function mouse move. Okay, in this case, do we really need the figure? because the source here is the figure. Okay, we will not need to deal with the figure. It was just useful for us to have that function. Okay, so if we don't need the source and we don't need the event either, okay, we don't need any of these. Good. Now we are in the function. Okay. uh we have here, when we click, okay, we have to be able to know when we have clicked the first time and when we have clicked the second time. Okay, why? Because when I am here, the function should not just start executing. I mean, it should not just start drawing lines and all the like. Okay, it is only after I have clicked the first time, okay, that the line should be able to. I hope you get the logic. So what am I supposed to do here? I want to be able to tell when I have clicked. Okay, so I'll create a certain variable here which controls when I have clicked. I will just call it count is equal to, and I'll ascribe the value of 1 to it. Okay, or let me say 0, to say I have clicked 0 times, right? And here when we click, what do we want? We want to set the value of count. We want count to be equal to 1. Okay, so let me see that. What's this? The value assigned to the variable count might be unused. Really? Yeah, true. Yeah, it's true, because I've created a value here. I've just changed the value here. Okay, good. I'm sorry, Krans, if I'm not using the variable. I'm coming. Okay, it's progressive and successive. Don't rush me. Okay, so if I run this, okay, so it is when I click, okay, count should be equal to, count should become 1. It was 0. Now it should become 1, right? Good. Um, hmm? No, there's a problem here, right? Are you seeing what I'm seeing? When I click, this is count that has been created here. Okay, so when I click, count should be equals to 1. It means there is a fundamental problem right there, right? Okay. Uh, this count is created, there is no underline, and this is, anyway. Let's just go ahead. Okay, let's behave as if I'm not seeing anything. It will tell us by itself. So when should this mouse move begin executing? It is if, okay, it is if count is equal to 1. Okay, that is when we want to start doing something with this mouse move. Okay, if count is not equals to 1, nothing should happen, right? But if count is equal to 1, it means that we have already clicked a first point. That's the way we will know that we have clicked a first point. Okay, so the fact that this count here does not underline itself means that we actually have to do something about it. Okay, so we have to create this count as a global variable, or should we just move straight into the matter? Yes. Okay, good. What we are executing so far, right, guys, is a script. Okay, it's a script, right? I want to transform it into a function. Okay, why? Because when it's a function, everything will work right. What we create out of these other functions, if I have a function here, let me just do that as I'm talking. Okay, if I have a function here instead, the function is supposed to have the same name as the name of the file. Okay, so I'll call it draw. This is the name of the file right here. Okay, so it's supposed to have the same name. I'll call it draw basic geo. Okay, so we have that, and I need to put an end to this particular function. So some things have changed now. Let me show you what has changed. I want to shift all of these. Okay. Yeah, good. So some things have changed now. Look at this count. It has become blue. Okay. Why? This is the parent function. Okay. This is the parent function, and these are the child functions, or what we call the nested functions. These functions are found within this function. Okay. That is why This is the parent function, this is the child function, a nested function. Okay, when a variable is created like this count is created in the parent function, all of the child functions have access to that variable. Okay, so that's why you see count in blue here, is to tell you that it is the same count that is here and the same count that is here. So if you want to create a variable that will be used in all of the or in some of the child functions, but you want the same variable value, okay, then you have to create it as you have to create it inside the parent function. Now, this is what we call a global. It will be global to all of the function. Now, here, look at this CP, for example, another variable that we have created. It's not blue, okay? It's not blue because it is a local variable. It belongs only to this child function, okay? So CP exists only within this function. It has not been created in the parent, okay? So if I create another function inside here, for example, let me call it test, for example, okay, that will be a nested function in another function, and inside this test I say CP, for example, then CP becomes blue, right, to indicate that the value of CP ascribed, let me just give something there, to indicate that the value of CP ascribed here is the same value ascribed here, okay, but that's not what we want. This is just to tell you that if let me create a CP here too. If I say CP is equal to 2, this does not become blue, okay? The CP here is not the same CP with the CP here, okay? When you create a variable inside a child function, another child of the same parent does not have access to that variable. It is a local variable defined only within the interval of that particular function, as you can see here, okay? So if I want the CP here to be the same CP as the CP here, then I'll need to create a CP here, okay, for example, equals 0. Then all the CPs here will be the same, okay? So a way of saying that at this level, the CP here does not affect my CP here at all, okay? Good. Wow, I hope that was understood, okay? I hope that was clear. So I got lost in explaining a lot of things. Where were we? Okay, so we were at count. We were at the level of count. Okay, so at this point, remember, let me just try to recapitulate. Okay, we created an axis. Okay, when we click on the axis, it gives us the first point right here, and then the count, that is supposed to be the variable that traces the number of times that we have clicked. The count becomes 1, right? Good. Now we want that when we move the mouse on our figure, okay, that line should be drawing itself. Okay, good. So what does this mean? I'll create something here, okay, because we need to know the coordinates of the line. We need to know the coordinates of the first point and the coordinates of the second point. So I'll create something called chord, okay, and I will just put the empty. Okay, I'll create it as an empty array. That is my chord. Okay, so the chord here is supposed to contain uh the x and the y value of each point. So row 1 will be the x and y value of the first coordinate, row 2 the x and y value of the second coordinate. Remember, this is not Cramer's rule. Okay, in programming, there is no, this is just a solution, okay, it is not the solution. So it means that you can actually do it your own way, right? So for the sake of explanation, there are things that I may have done it differently if I was doing it for a project, for example, okay? So but for the sake of explanation, I can do it in a certain way that will be understandable for you. So there is not the solution, there is a solution, okay? So this is just a solution. So what I'm doing here is proposing this chord the way you're seeing it, okay, that will enable us to store the coordinates of every single line. Why? Let's go to the command window again. Hope you're not tired already. Okay, so let's go there again. You remember we drew a line, right? And the line came out very, very, very simply, like this. Okay, oh, line. And the line came out very simply like this. Okay, you remember that? Good. But here, we want to be able to tell MATLAB the coordinates of our first point and the coordinates of our second point. Well, the line allows us to do that. Okay, there's another construct of drawing lines that allow us to do that. So if I say line and I open the bracket, what is expected? We have x and we have y. I think we should go to the help just to spy that. Let me plus again. Okay, so let me type here line and enter. Okay, so at this level, this is it here, line xy. So what does it tell you? Line xy plots a line in the current axis using the data in vectors x and y. If either x or y or both are matrices, the line draws multiple lines. Unlike plot function, line adds the line to the current axis. That's a long story for nothing, right? Good. So listen, this x vector here, okay? This x vector will contain the x coordinates of point 1 and point 2, right? For our case, and this y vector will contain the y coordinates of point 1 and point 2. So this is where we will have x1, x2, and this is where we will have y1, y2. Okay, so let's say, for example, for the sake of illustration, let's say we want to plot a line. The coordinates of the first point, okay, let me put it in comment. The coordinates of the first point are x1. Let me put it like that. Coordinates of first point, point 1. Point 1 should be equal to, it's normally represented in x comma y, right? So it will be 2, let me say 2 comma 3. So it means you agree that this 2 here is what is x1, okay? And this one here is y1, this 3, right? Good. And we want point 2 to be equal to, it's just an example, okay? 3, the inverse, comma 2, okay? So you agree that this 3 here is what? Is x2. And this 2 here is y2, okay? So that's our example. That's what we want to, that's the line that we want to draw. Well, we'll just go ahead and do line, okay? Good. What the line expects is the x values first. So we'll create a vector here that contains the x values. Okay, the vector will contain x1 first, then comma x2, which is 3. Okay, we'll close the vector. Then we are going to go for the y value. The y values will contain what? Y1 3, comma what? Y2, which is 2. Okay, and then we close that. So if I press enter, okay, that's what is drawn. Okay, this is our line right here, okay, which has coordinates for point 1, coordinates 2 3, as we have here, right? 2 3 for point 1. I love this, my love. I love this. It's no longer coming. Okay, so point 2 3 2 and point 1 2 3. You see that? Very simple. Very, very simple. Now, the other thing you should know is that just like axis and figure, I can store my line in a certain property. Okay? I can store my line in a certain, I can store my line in a certain property, in a certain variable, L, such that I can control the line. Okay? So let me go ahead and close this. If I run that, I have this line. Okay? So L now becomes what? L becomes the variable that controls this line. Just like axis and figure, okay? If I want to change the color of this line, I can simply set uh, the color property of the line color. You see how useful this is, right? And simple too. I can simply change it. For example, I'm not touching the green yet, right? To green. Okay. And if I come this way, what happens? The line has turned to green. So exactly axis and figure, exactly the same thing. You see that? Okay. Now, what you should also know is that these values, good, they are already shown here. The 2 and the 3, which represented the x values, are stored in the x data property of the line. Okay, and the 3 and 2 are stored in the y data property of the line. Okay, so if I want to change that, so for example, we are moving the line, right? You see that we're moving the line, and the x value and the y value of the second point will be in constant motion. Okay, as we'll be moving the line, the x and the y value of the second point is what will be changing, right? The first value will not change, it's the same point. But as we are moving, the x and the y of the second line is what will be in motion. So we need to know how to change that, okay? So look at this line again very well. Okay, I will set, this is normally 2, 3, okay? So I will set the value of this, let me just say this, or let me say this first point, okay? 2, 3 is the first point, right? Yes. I'll set it to 0, 0, and you'll see how the line behaves now, okay? So we will set the x data property, because it is the x data that contains the x values of the line, okay? So we will store its properties. It will no longer be 2, 3, it will be 0, 3, right? Because we want to change it now to 0, 0, remember, okay? So it will be 0 comma 3, okay? And then we'll set the y data property. We'll set that to 0 also, and 2. Okay, so here we are setting, it means it is the same line that we are just changing. We are just changing the x and the y data. So let me press enter on that, and what happens? Okay, you see that it is now 0, 0 for the first point. Okay, but the second point has not changed. It is still 2, 3, right? The way it was, rather 3, 2. It is xy. Okay, the way it was 3, 2 right here. Hope that is understood. So let's go ahead. So what am I saying? I'm creating this code for. I'm creating this code to store the data. So what does it mean? At this level, when we have clicked, we have calculated, let me put a semicolon here. We have calculated the value, this CP represents the X and the Y coordinates of the first point as we saw it. So we want to store now that CP into code, okay? We will say code will be equal to CP. But is it just code that is equals to CP? Oh, we'll see that, okay? Ha! Are you seeing this? It's dangerous, okay? You cannot say, okay, don't put X and Y there. We don't know what X and Y stands for. Good. So we have chord is equal to CP. That's when count is equals to 1, okay? Now, what happens when count, rather, what happens when we have clicked? We want it to move, right? We want it to move. So at this level, ah, the first thing we need to do is to collect the, this is where things become interesting. The first thing we need to do is to collect the new point, okay, where the mouse is. That's the first thing, okay? So as the mouse is moving, on which coordinate is it at any given time t? And we can collect that, right? It is simply by using this same series of command, okay? That's all. Okay, so we just say CP get the current point, and then CP is equal to that. So let's see this in action before I actually continue. Okay, so let's go again here and here. Good. So if we run the basic Joe, Look at this. When I'm moving, nothing happens. Nothing happens. Why? Because I have not yet clicked. Okay. Count here is still equals to 0. But when I click, hey, I have clicked, guys. Error. Oh, there is an error. That's true, right? Yes, that's true. That's true. That's true. And guys, what is the error? What is the error is that we are still calling here source, whereas there is no source here. Okay, it is gone. Okay, but there is a function in MATLAB for figures and axes that enable you not necessarily to create a variable, but to be able to get the handle of the axis or to control the axis. It's simply GCA. Okay, GCA stands for get current axis. Okay, so the axis that is there, the axis that you're using right now, it will be stored here. So having GCA here will be the same as me saying A. In this case, in this particular case, it will be the same as me saying A is equal to axis of that and then putting that A here. Okay, you can always go to the help and check get current axis GCA. Okay, so but let's use get current axis. It's not source in this particular function, okay, because there's no source there. GCA. Good. Let's try that again. CLC and draw. Okay. So I was saying, when I do this, nothing happens. It is only when I click that if I am moving, you see that. So where I am right now, these are the coordinates of the point. See here. Okay. The coordinates of the point are showing. This is new, 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 new. So at any given time t now, because of the button of the Windows button motion function, I know exactly where I am found. Are you seeing that? So now we want to draw a line that goes from where I click the first time to where I am found at any given time t. That's what we want to do now. Okay. So I'll go ahead and close this. So how do we do that? How do we do that? So what I'll do here is I'll first of all initiate a line up this way, okay? And that line has to be global. Let's call it lean. Okay, let's call it lean, and we'll just empty it. Okay, we'll initialize it there because we want the lean variable to be accessible to all the functions. Okay, so at this level, I will just create lean. Okay, but the way I will do that is by having the same x and the same y such that it is just a point. Okay, you understand what I'm saying? Such that it is just a point. Okay, so let's go ahead. What will be CP of 1 will be x, right? CP of 1 will be x. Okay, so what we can do here, now let me not complicate things and scare people away. This will be CP of 1, CP of 1 for XX, okay? And then I will have the same thing for Y. Okay, so here 2 and here 2. Okay, so that it just creates a line. That's all. Okay, so what have we done wrong again? Why is it doing that? Let's go ahead and read the error. There was no error. What happened? Okay. Sorry, we don't have to click again. Okay, so again. Let's execute that. Let's run that. Let's run that. Run. Okay. What? There is something wrong somewhere. They say index in position 1 is invalid. Array indices must be positive. But what's happening? Are we indexing something wrong here? I don't think we indexed something wrong there. Or did we? No, there should be no error here, okay? There should be no error. This is CP of 1, CP of 1. We have not changed the value of of CP. Okay, so there should be no error here. And I think maybe the error is simply because we've not yet programmed what should happen down this way. Okay, so let's just go ahead and program that. So you create a line. Okay, you create a line right there. So at this level, um we want to be able to move our mouse, okay, and what happens, the line should follow. But we already have the coordinates of the first point, you remember. Coordinates of the first point are stored in chord at the level of the first row. That is where they are stored, okay. So we can get that, okay. We'll simply say um um we have to set lim, which is a line that we created right here, okay. We have to set its x data to something, okay, while we are moving the mouse, right? And we also need to set its y data to something while we are moving the mouse, okay. So what value are we going to set its x data to? The x data has to be set to, let me put it this way, okay, and here this way, okay. The x data has to be set to the x coordinate of the first point always. And in this case, what will it be? It will be chord of 1, right? At this particular phase, it will be chord of 1, or let me just say chord of 1. No, it will be chord of 1, okay, at this particular phase. What will be the value of the second coordinate in this case? The second coordinate will simply be equal to CP of CP of 1. Okay, remember, this CP and this CP, not the same thing. The CP here it will contain the coordinates of the second point as we are moving. Okay, so we want the x value of the second point each time we are moving. And here it is the same thing, but it is 2 2 2 2 2 2 2 2 2 2, right? It is 2, and here 2. So let's see, that should work, right? Let me close that. MATLAB, CLC. You behave yourself. I don't want any stupid errors. Don't have time for that. Good. So nothing happens, but when I click, there is a problem, guys. What did we do wrong at the level of line 12? Let's go to line 12. What is it we are doing? Oh my God. Oh my God. It is not lean here, right? It's supposed to be line off. So it is lean is equal to, oh my God, that's horrible. Lean is equals to line off. Oh, but none of you told me that. Okay. I'm not reading the comments now, right? So let's run that. So if we run that again, when I'm moving, nothing happens. But when I click, okay, look at what is beginning to happen. Okay, we're beginning to have a beginning of behavior. Hey, but what happens? We have, oh my God, we have our axis simply misbehaving and changing x limits and y limit at its please, as it pleases, right? So what we need to do actually, we have the x lim and the y lim modes of these axes that are auto. Okay, it means it automatically changes according to how it wills, right? We want to set them to manual so that it is fixed, okay, so that we can see our lines actually moving. Okay, so remember everything I'm saying. If you don't understand, you have the documentation. You can always go and do more research. X lim mode, we want it manual, okay. And y lim, you remember, I hope you remember what y lim is, okay. Y lim and mode, we also want it manual, okay. So let's try that, and when we run, look at this. Oh my God. Look at that. How beautiful is this? Okay. This is just to tell you guys, okay? There is everything you see, every software you see that exists presently, it has been programmed, okay? It has been done by some code. It's not magic, okay? So you can do it, I can do it, we can all do it. It's just to sit down and study. And if we have this power to automate things, boy, I don't tell you where we are going to. It is useful in every single sphere of existence. We are moving to an era where we want robots to do everything for us, okay? And you want to have the skills to be able to automate those robots. If not, you will not be relevant for the jobs that are coming ahead, okay? Good. That being said, you see that? This is the initial one we want, okay? But at this level, we are not done, right? This is just a beginning because now when we click, it should draw this line. Okay, when we click, it should draw this line. And then from where we have clicked, it should go on to draw the next line. Okay, so I can see that time has gone. I think we will keep the drawing of the square and the circle to another session. Okay, so this session will just focus on the line. I think it is enough to digest for a session. Okay, so we'll just focus on this, and then next session we'll do a rectangle, and then the other session we'll do circle. Okay, so I hope that's cool by you, so that I don't take too much of your time this morning. I'm sure you have other things doing, and I'm sure you also need time to be able to digest everything that we've said here. Okay, good. So, how do we do that? How do we do that? We are at this level now. How do we do that? Okay, so this is where we are. Good for us. What happens is that when I click again, listen, it's English I'm speaking. When I click again, okay, what is the function that will execute itself when we click? Well, it is simply this button down function that will execute itself, okay? So this is where I'm supposed to control when I click again, okay? Good. So when I click again, when I click again, when I click again, then it is supposed to somehow uh, have that behavior. Okay, it's supposed to store the final value that was taken here. Okay, and then do what it has to do. Okay, so how do we implement this? Question. How do we implement it? Well, I see that it will be necessary for us now to actually have CP as a global variable. Okay, why? Oh, not necessarily, not necessarily. Okay, we can always go ahead and be also storing the value of CP here in code, but I don't think that would be useful. Okay, or we still maintain this code. Why? Because when we click, CP will always get the current point, and CP will always do this. Okay, when we have clicked on a current point, so it will always do this. But the problem now is at the level of count and at the level of the storage of the coordinates. Okay, and making sure that we are drawing a new line, not just this. Okay, so what happens here? We need to change this coordinate. Okay, it is no longer chord, but chord has to be able to increase and store the various coordinates of the different lines that we are drawing. Okay, so here we need to do concatenation. We want to say chord. I'm sure this is where many will become lost, for sure. So we want to say chord will be equal to chord, okay, semicolon CP. Okay, so we want to say chord will be equal to the previous coordinates that were there, okay, and then we just go to the next column and add the new coordinates that we have just clicked on. Okay, so count here should always increase. So count should trace the number of times that we have clicked. So we don't want to say just count is equals to 1. No, we want to say count should be equals to count plus 1. Okay, sorry, plus 1. right? So that when we click a first time, this count is equals to 1. When we click a second time, it takes the previous value of count, which was 1, and adds to 1 to give us 2. So this count will always represent the number of times that we have clicked on the axis, okay? So when we click a first time, it will be 1. We click a second time, it will be 2. We click a third time, it will be 3. Because each time we click, this function is executed, okay? And the moment it does that, automatically it introduces this, okay? And the other thing we want to do here, okay, is uh remind me, what's the other thing we want to do again? Okay, yes, we also want a new line to actually add itself, okay? So we want to say len will be equal to, so we can create it as handles, will be equals to len, the previous lines that were present, okay, semicolon, a new line that will be created, okay. If that is done, then we are good to go, okay. So now here it is not necessarily if count is equal to 1, okay. No, not necessarily. We want to say if count is what, greater than or equals to 1, okay. Not necessarily strictly greater than 0 or greater than or equals to 1, okay. Or let me just say greater than 0, just to say from 1 upwards, okay. So to say that each time we click, when we have clicked the first time, then that behavior has to continue. That behavior has to continue. But then how does the behavior continue? That's the question. How does the behavior continue? Well, we will always get the new point. We will always get this, right? We all want to get the coordinates of where our mouse is found. But then this behavior right here is what changes dramatically. Okay? So how is it gonna be? We want lean, yes, but it is not lean per se, right? It is lean of the most recent line that we have just designed. So this lean becomes a vector of lines. Okay, so the first row will be the first line, the second row the second line, the third row the third line, the fourth row the fourth line, and so on. And then here we now have a vector of lines. Okay, so we want the last line, which is the most recent line that we have added, so it will be lean of end that we want to be moving in that pattern. Okay, so if I'm drawing here, AutoCAD, okay, so when I draw pap, okay, this is the first line. If I click, okay, the moment I click here, okay, a second line is being drawn. A second line is automatically being drawn from the button down function. Okay, now this is this line that's supposed to have, so this is the most recent line and the last line in the lean vector. Okay, I click again and so on and so forth. Okay, so let's go ahead. So this is lean of end. Now how will the x data vary according to what we have edited up this way? It will no longer be chord of 1, no, right? No, it will have to be chord of end. End here represents what? Represents the most recent point, right? But we want what? Its x coordinate, okay? And it will be cp of 1 always, because this is what controls the movement. And here we have end again, but we want its y coordinate, okay? So here we have cp of 2 always. Will this do? I think this will do, right? I think. Anyway, let's just implement, and if there are any hoity-toities, then we can correct that. Good. So at this level, I have this. If I click, wow, I'm clicking and nothing is happening. Guess why? Well, look at where my mouse is found. Okay, my mouse is found on the line. So actually where I'm clicking now, I'm not clicking on the axis. Okay, I'm actually clicking on the line here. Okay, so when I click on the line, it's trying to execute the button down function of the line, but there is no function to execute there. Okay, and this line is causing us not to be able to click on the axis. So what we want to do, we want to set the heat test property of the line to off. Okay, the heat test property of the line to off makes the lines transparent to any clicking callback. Okay, so that when we click, we are clicking not on the line, we are clicking on the object that is found behind the line. Okay, so let's implement that. So what we are saying is that when we are creating our lines, we want them to have, come on, we want them to have the heat test property. I hope it is double T here. Anyway, we want the heat test property uh set to off. Okay, good. So let's go ahead and try that again. If I run and I click, wow, 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 oh my god. So that is that behavior. Okay. So I know that certainly towards the end of the code, many got lost, but it's not a problem. Okay, so we'll make sure that we make this code available to you so that you can get the code and experiment with it. Go line by line and follow the tutorial again. Okay, try to execute it, try to implement it. That's also an advantage of teaching. You must not understand everything as we are teaching. Okay, you mustn't understand everything, but the questions, I'm open to the questions. Okay, you must not understand, as I was saying, everything when we are teaching. It's good for you to get what you learned and then sit down and then go line by line, because that is actually how you also get it for your own self, not just something that you heard from somebody. Wow, that was a session. Okay, that was a wonderful session. I hope that you guys enjoyed it. I hope that it was useful knowledge that you will be able to implement from now henceforth. Hmm. uh thank you very much, guys. Thank you so much for being there. Thank you for being present. Even those of you who may not see the relevance of this for now, and but who stood back to actually learn some new skill. uh Thank you for taking your studies seriously, because when you take your studies seriously, you make our work relevant. Okay, so please do not leave without subscribing to our YouTube channel. Okay, Computational Engineering Academy. Do the YouTube search and then you subscribe. Or if you're watching this video now, just click on the subscribe button below and click on the notification bell. Okay, make sure to check the description constantly, uh, to be able to have the file, to be able to know where to contact us, to be able to go to our website and browse and all the like. Okay, uh, I was very, very glad to have this session with you guys. So, thank you very much. I will answer the questions and all the misunderstandings. I will answer them in different videos so that they are, in fact, I'll create videos that are oriented towards answering those questions so that you have detailed answers to them. So if you're subscribed and notified, you will know when a new video is uploaded, and that video may just be an answer to your question. So please invite more people. Okay, you don't need to wait till when there is a session or something. Just go ahead and invite them. Let them come and subscribe. Okay, let them just come and subscribe, because we will be live. For example, the rectangle session, I'm not is not for next Saturday for sure. Okay, during the week I will do it. During the week I'll do the circle session during the week, and all of that will be live, and you don't want to miss that. Okay, you don't want to miss that. So thank you again for being there, and I tell you, have a wonderful day and happy MATLABing. Bye bye.